Okay, here we go. Notes. But maybe you're just guessing. Okay. You did a guess? Okay, but once you realize why and how to look at it, it's going to be so easy. Okay, notes, we're simplifying radicals, right? So just going to put radicals. And this is for worksheet 3, right? Because we did worksheet 1 and we did worksheet 2, and we're now on worksheet 3. Okay. All right. So let me ask you this. I know what the answer for, let's do this example problem right here. I just put EX example. Why is the square root of 20, what's the answer for the square root of 25? 5. Why? Okay, because since we're just looking at radicals, which are actually, these are square roots, right? Since we're looking at we're just simply focusing on square roots, we have to remember the fact that there is a 2 right there, but they're not going to write it. It's already understood that there's a 2. When it's a cubed root, they'll write a 3 or whatever. But even though they don't write it, you got to know it's there. But for square roots, you know that you're looking for what? The same number twice, right? 2 times. It multiplying to itself. It's 2 of them. All right? And if you get a set of 2 of the same number, it comes out. Right? It comes out as a whole number, right? Yeah. And that's why the answer for the square root of 25 is 5, right? Okay. So here we go. Number 1. Now we're going to be multiplying. We're going to be multiplying radicals. So what's the square root of 10 times the square root of 3? Well, they don't have any common factors. I know 10 is 2 times 5, but this one's not a 2 or it's not a 5. When there's no common factors, what do you do to multiply radicals? You just put them under the same one and then you multiply it. And the answer for this one is, okay, see, there's no common factors. 3 is just, we don't count 1. 1 is everywhere, but 3 is just 3 and 10 is 2 times 5. But there's nothing they have in common. When they have no common factors, we just multiply and then that's it. It just stays like that. Okay, number 2. What is the square root of 6 times the square root of 7? Do they have any common factors? No. 6 is 2 times 3, but 7, there's nothing common, right? There's nothing in common. Guess what? It's just what? Whatever 6 times 7 is. You put it together as 1. 6 times 7 is... Okay, so it's the square root of 42, yeah? Okay. Now look at this. Number 3. What is the square root of 17 times the square root of 17? Oh my God. The answer is 17. Hello? Don't tell me you're multiplying 17 times 17. Oh my God, get out. Why is the square root of 17 times another square root of 17? I know the answer is 17. Because don't you put them together under 1? And aren't we looking for 2 of the same number? What do we do when we have 2 of the same number? Do I need to know what 17 times 17 is? No, I don't need to know that. Why would I need to know that? If I already have the same number twice, it comes out as a whole, right? So what's the answer for this one? Huh? 17. Oh, I thought you said 1. Okay, number 4. What is the square root of 6 times another square root of 6? It's 6. Why would you do, 6 times 6, 36, and then you're like, what's the square root of 36? Oh, yeah, it's 6. It's right there, right? Because there's how many? Just remember, you're always looking for how many? 2. Remember, a square root has a 2 right there, but, pairs, 2. And if you got 2 of the same number, it's coming out. It's coming out, right? And if there's nothing left over, well, then the answer is just 6. I don't need to know what 6 times 6 is. Just like over here, I don't need to know what 17 times 17 is. If I have 2 of them, it's out, and it's 17. Okay, number 5. Number 5. What is the square root of 2 times the square root of 2 times 3? Well, what is multiplication? Remember, multiplication, we can put it all together. And when I have to multiply all these numbers? No. I actually want them factored out like this. Because when I put them together, what am I going to have? I'm going to have 2 times 2 times 3. Does everybody agree? I don't care that 2 times 2 times 3 is 12. I don't need that. I want them already broken up and factored out like this. And what am I looking for, you guys? A number that is going to appear what? Twice. When that number appears twice, what happens to that number? It comes out, right? It comes out of the square root. And if there's only one of each of a number, does it come out? No. What's the answer here? 2. The 2 comes out because of this set of 2, right? We're looking for pairs or sets of the same number twice, right? And does everybody agree the answer is going to be 2 root 3? Yeah. All right, moving on. Number 6. Let's make it more interesting. Number 6. What is the square root of 8 times the square root of 16? I don't want to multiply these numbers. Don't multiply them. Oh no, I don't like 16. I'm sorry. I don't like 16 because the square root of 16 is already a perfect square root. Sorry, I didn't mean that. Can we change this? Sorry, change this to like 40 then. Sorry. I'm sorry. 8 times 40. Don't multiply 8 times 40. Can we find a common factor like Natalie said, a greatest common factor? Does everybody see that 8 goes into 8 and 8 can go into 40? I know 2 goes into 8 and 2. I know 4 goes into... No. Greatest common factor, 8. So does everybody agree this would be the square root of 8 times the square root of what? What is 40 going to be? 8 times 5. You see that? I don't want to multiply this and get 320 and then try to figure that out. Why would you do that? And then now that I see this, I know you can tell me the answer, but I want to see this step. I want to see you put it all together under 1 and show me what? 8 times 8 times 5. And what's coming out? The one that has 2, right? The one that the number that's coming out twice. I know 8 times 8 is 64, and then the 64 is 8. But just why would I need to do that? Everybody agree this comes out? Answer is 8 outside and 5 inside. The answer is 8 root 5. Does that make sense how we need to look at these? Okay, so let me give you some good ones. Number 7. What about the square root of 12 times the square root of 10? What would be the greatest common factor between a 12 and a 10 to get a set of numbers that match? And I think it's just going to be 2, huh? So 12 would be 2 times 5, and 10 would be... who put 2 times 5? I'm thinking of this one. 2 times 6, and this would be 2 times 5. All right. Now I'm going to multiply, which means I'm just pretty much going to put everything under the same radical. And I'm going to put what? 2 times 2 times 6 times 5. You guys see how to approach this? And what's coming out? I know the 2 is coming out. So that's 2. And just always check and see if anything here can have and any of these have any common fact? A 5 with no, huh? So it'll be just 30, huh? We'll just multiply 6 times 5 and it's 30. Is that making sense there? Okay, number 8. All right, what about the square root of 20 times the square root of 8? What is the greatest common factor on these so that we can find 2 numbers that they both have in common? Greatest common factor is 4. 20 is 4 times 5. 8 is 4 times 2. Now writing it all under the same radical, that'll be 4 times 4, and then times 5 times 2. What's coming out? The 4s are going to come out. Always check here and just to see if there's something else that do they have a 5 and a 2 have anything in common? No. Final answer? 4 root 10. Okay, number 9. How about, go ahead and try that one on your own. Mm-hmm. Up, sorry. I didn't move it. What's the greatest common factor for 8 again? Oh yeah, you're right. 24 is 8 times 3. And then 40 is 8 times 5. Yeah, this is the one on the board that I was asking you earlier today, that nobody can give me the final answer. Now you see how to look at this? Easy. So we put it together now, and there's 2 8s. Oh. And then a 3 and a 5. Okay. We see it now? That's going to be what? 8's going to come out, and does that have anything, nothing in common there? No. You guys see the 8 root 15 there? All right, I think you got it. Let me give you one more. Nah, that's too easy. Bless you. Let me give you a tough one. Oh, okay, I like this one. I'm not going to give you any hints. Number 10, the square root of 12 times the square root of 15. And I guarantee half of you will not get it right. Anybody got an answer? 3 root 20? Okay, I'm just going to write it down because that's what you're talking about. You guys are telling me 3 root 20. Anybody got a different answer? You multiply them? That's what we're not doing. No, we're not trying to get a bigger number. No. Nope. And everybody got this answer? So nobody got a different answer. Oh, then I was wrong. I said half of the people were going to get it wrong. No, all of you got it wrong. That's not the answer. Here we go. I'm going to do it right here. Don't get mad. The square root of 12 times the square root of 15. That's the problem, right? Here you go. The greatest common factor is 3. Did you get that part right? Yeah, you still got it wrong. 12 is 3 times 4, and 15 is 3 times 5. Did you do that? And you still got it wrong. And then you wrote this. I bet you wrote this. And then you wrote 3 times 3 times 4 times 5. And you still got it wrong. Thank you. These 3's come out because there's 2 of them. And the 4 comes out because the 4 is a perfect square number. Isn't 4 a perfect square number? Or you want me to break it down so you can see 2 times 2? No. You see, I told you to look. Always look again at the numbers left. If they have a common factor or one of them is a perfect square number, 4 is a perfect square number. Right? So what comes out? The 3 comes out because of these 2 3's right here, so it comes out as 1. And the square root of 4, 4 has a square root. What's the square root of 4? Not 4. It comes out as a 2. And what's the only thing left inside? A 5. Okay, what's the final answer for this one? Yeah. All right. We're good or another one? What do you guys think? You good? You know what you need to do? One more? Okay, one more. All right, let me go with the square root of 32 times the square root of 48. Oh, big numbers. What did you get for the GCF? Yeah, the GCF is actually 16, but I'm going to do it the way you're doing it. First, let me do it with the GCF, which is 16. If you did 16, this would be 16 times 2, because 16 times 2 is 32. And this one would be 16 times 3, because 16 times 3 is 48. And if you did it with the 16, you're going to be done pretty quickly, right? Because then that would be 16 times another 16 times 2 times 3. Everybody see what the answer is going to be right here? What's going to be the answer right here? The answer is going to be 16 root 6. Yes? Okay, let me do it your way now. Because I know you didn't know the 16 times tables, but let me do it your way now. Are we good with that one? I'm going to do it your way. 32, root 32 times root 48. You guys found 4. Okay, it works. It is 4 times 8. And it is 4 times 12? Yeah. It is 4 times 8 and 4 times 12. Which is going to give you what? 4 times 4 times 8 times 12. Yeah. But what you failed to look at is these two. I told you, look again. Can these two have a common number right here? Yeah, they do. So let me take this out right now, and this is 4, and I still have 8 times 12. I could still find something in common here. That would be what? Well, 8 is going to be another 4 times 2, and 12 is going to be what? You see how they have another set of 4s coming out? You guys see it? Yeah, you don't want to do this double. This is what's going to happen when you don't find the greatest common factor. You're going to have to like almost feel like it's doing it twice. So I got 4 times 4 times 2 times 3. Well, another 4 comes out. That 4 multiplies with this 4. And what stays inside? And that's why your final answer is, what is it? You'll get to the right answer. I mean, if all your steps are right. But you don't want to do double, triple work. Find the greatest common factor, and it won't take you long. Okay, but that's how you want to look at these, yeah? That one was a little bit tougher, huh? Okay.